Sunspots are 3,697 and are 3,664, the danger of solar activity to Earth. Sunspots are 3,697 and are 3,664, are once again in a position directly facing Earth and will soon begin spewing huge streams of plasma in our direction. If these solar flares reach our planet, it could result in severe geomagnetic storms. Scientists are already warning of the possible consequences, expecting that in May 2024 we will face some of the most powerful storms of the last 20 years. The intensity of solar activity is once again increasing, and it is expected that the peak of the current solar cycle could trigger the strongest solar storm in observational history. In May 2024, an unusual light phenomenon occurred over Europe. In some regions, the night sky was colored in blood-red hues, while in other places green or blue aurora shone. These magnificent light shows, which are usually only seen in polar regions, were the result of a powerful solar storm. The glow spread far south in the northern hemisphere, while in the southern hemisphere, the colors could be seen far to the north. The Earth was exposed to a particle flux so powerful that the magnetic field's protective mechanism did not work properly. The electromagnetic particles penetrated the atmosphere, providing us with not only mesmerizing auroras, but also a number of problems. Fortunately, after the worst storm in 2 decades, only a few regional power providers reported grid failures. Elon Musk was relieved to publish a graph showing how resilient his satellites were to the storm. The scenario could have unfolded differently. A solar storm as powerful as the May flare could have triggered a global crisis. But now the huge sunspots responsible for the storm are beginning to gain strength again, and scientists are anxiously watching the activity of sunspot R3664. Who would have thought that a torch of destructive power could erupt in just a few weeks? Scientists closely followed the events on the Sun, and even amateur astronomers could see this amazing phenomenon almost with the naked eye. Within a few days, small sunspots merged to form a giant sunspot, which at the time of its appearance on May 9, 2024, already threatened our planet. NOAA's GOES-16 satellite detected a flare that sent a stream of particles in our direction. The starting point of this violent activity was sunspot R3664. Shortly thereafter, security systems issued a warning of a G for class geomagnetic storm. Such storms are classified as severe on the geomagnetic storm scale, and even at their worst, they can cause disruptions to power grids and satellite technology, as well as disruptions to navigation systems and anomalous phenomena in the atmosphere. The storm hit Earth as R3664 re-released a stream of particles. On May 10, 2024, satellites recorded an intense X-58 class solar flare, and this storm raged through the weekend, once again giving us magnificent auroras, but also causing power problems, R3664. On May 11, 2024, geologists recorded for the first time a significant stress in the Earth's magnetic field. Charged particles from the Sun interacted with the atmosphere so actively that regional weaknesses and holes in the magnetic field appeared. It is still difficult to assess the long-term effects of such disturbances, but we can only hope that our planet will survive the ordeal. No one can accurately predict what will happen if the Earth's magnetic field fails. In the worst-case scenario, it could lead to an increase in radiation as well as a loss of atmosphere, which could have long-term effects similar to those seen on Mars. The situation continued to evolve, and on May 14, 2024, scientists predicted a G5 storm that could be the most serious test for our planet. The scientific community warned of the day when a G5 storm would become a reality. Storms of this class are associated with powerful coronal ejections that throw even more streams of particles toward Earth. These solar events have again led to prolonged geomagnetic storms. On May 27, 2024, we saw another powerful solar flare, and this time shortwave radio transmitters and receivers around the world failed. International emergency communication systems, maritime and aviation radio communications, and military communication systems were affected. Ordinary people from all over the world watch the auroras with delight in regions where this phenomenon is not normally found. The last geomagnetic storm in May 2024 affected the magnetic field, even in the deep ocean, disrupting underwater compasses and underwater communications. Energy companies reported regional problems with power systems, and a number of satellite operations were disrupted. Sunspots are 3,664 and are 3,697 pose an ongoing threat. Who would have thought that we could expect threatening emissions from the sun around the clock? Hardly anyone on Earth realizes this danger. Sunspots occur all the time, and they don't even have to be as large as our 3,664 to cause us problems. Even smaller sunspots that occasionally appear can cause powerful solar flares. Sunspots form as a result of intense magnetic activity on the surface of the sun. The sun is made up of different layers, and the magnetic field is created mostly within it. When magnetic fields break through to the surface, they prevent hot plasma from rising from within, making the affected areas cooler and darker. These are the sunspots that can be seen with the naked eye from Earth or with specialized telescopes. Solar observatories, such as SOHO Solar and Heliospheric Observatory, monitor the sun around the clock. SOHO is a static space probe launched in 1995 by a joint effort of the European Space Agency and NASA. It observes the sun at a distance of about 1.5 million kilometers from Earth, and its orbit is very similar to that of the new James Webb Space Telescope. On Earth, the largest solar observatory is located at Haleakala Volcano in Hawaii. These observatories are different because they work with special filters and shielding technologies to prevent damage from constant solar radiation. In April 2024, researchers in Hawaii and experts from the SOHO facility observed the formation of R3664, a giant among sunspots at the rising peak of the solar cycle. The development of larger and more threatening sunspots is normal, but this time was different. For the first time since 2003, R3664 was once again targeting Earth. It's hard to believe that there are areas on the Sun 15 times the size of our planet. These areas are cold and dark. Sunspots are formed by normal processes inside the Sun where gases, plasma, and particles interact in different layers. Magnetic fields cause shocks that are hard to imagine. Billions of tons of boiling hot matter rise, fall, bubble, or cool dramatically. When magnetic fields swirl within layers, a sunspot forms that is much darker than surrounding regions and cooler because of a cooling effect known as magnetic peregrine. Suddenly, a huge amount of energy is released, resulting in solar flares or coronal mass ejection (CMS). The difference between flares and CMS is the nature of the formation and the amount of energy released. Flares are caused by the rapid release of energy, light, and high-energy particles from magnetic fields, while CMS are huge bubbles of plasma and magnetic fields hurtling into space. When CMS reach Earth, they can cause geomagnetic storms, disrupting electrical systems, satellites, and leading to intense auroras. Outbursts usually consist of less dense streams of particles, but they are faster and can hit us in minutes or hours. CMS carry a large mass, but they take days to reach us. Threatening changes in the Sun's activity continue. R3664 has transformed into R3697, and sunspots are beginning to gain strength again. We are only at the beginning of the most intense solar activity, and the expected peak will be in 2025. If the current powerful flares are just a precursor, we should be preparing for extreme stress on our technology and systems. Subscribe to our channel so you don't miss new exciting videos. The events described above emphasize the fragility of our planet and technological infrastructure in the face of powerful natural phenomena, such as solar flares and coronal mass ejections. It is important to recognize that geomagnetic storms and other forms of solar activity can have a significant impact on our daily lives, disrupting satellites, communication systems, and even power grids. In my opinion, these phenomena remind us of the need to invest in developing technologies that can counter such threats. This could include improved protection of satellites and power grids, developing new materials and technologies that can effectively protect satellites and infrastructure from high-energy particles. Modernizing communication systems, developing redundant communication systems that can function in the face of severe geomagnetic storms and solar flares. Awareness and training, strengthen educational programs and public awareness of the possible effects of solar activity and develop strategies to minimize damage. International cooperation, strengthen cooperation between countries in monitoring solar activity and sharing data to better predict and respond to threats. Advancing science and research, continue and expand scientific research to better understand solar processes and their impact on the Earth. This may include launching new space observatories and satellites to more accurately monitor solar activity. These measures can help us not only prepare for future challenges, but also minimize potential threats to our civilization. Modern society is highly dependent on technology, and any threat that could disrupt it must be considered with special attention. It is important for us to remember that the sun is not only a source of light and heat, but also an object that can affect our planet much more than we tend to think. It is therefore important to be prepared and learn to adapt to the changes occurring in space.